So as Desmond mentioned, I'm Ludwik Bukowski. I came from Krakow for the EMPEX LA. So basically, as a Erlang solution software developer, we have to deal with a lot of different systems and architectures. And based on my work, I have prepared a presentation that helps developers how to monitor their system. So for the purpose of the presentation, I have created application. I called it EMPEX Cookbook. And basically, it's about creating recipes. It's based on Phoenix framework. So it's pretty straightforward. So we have a list of the recipes. We can delete them. We can create new recipe. Let's call it carbonara. Like boil pasta, like egg. So the idea of the carbonara is that you need to boil the pasta, cook the pancetta with garlic, and at the end we mix it with the yolks from the egg. And the crucial part is that you need to make it fast so that the eggs doesn't curdle. So I have created the carbonara. It works. It's here. That's fine. So it's working with Icto and Phoenix framework, and we have web interface for that. As we introduce the devices for our application, I have used GraphQL protocol. GraphQL is a query language that gives you opportunity to define your own schema or type system. So for example, I can query my application for my carbonara that I have just created right here. The idea is quite simple, that it returns JSON. We define the fields that we'd like to query. Let's say I want the user with his email who created the recipe, and yes, we have that. I have created the recipe here. So it's based on Absinthe framework. Just one slide how the Absinthe really works is that we need to create a field with, here is a recipe that returns the recipe object, and the object is defined like this. It uses DSL for fields, and we define the recipe function, resolver function for the recipe, and it's called find by name, and it just returns the recipe from the database. So the owner of the CEO of our application is Chief. He's like tough Italian, like very expressive guy. And the issue is that once he created the application, he doesn't know any numbers. So he doesn't know how many people actually use the application. And he'd like to see some rates or the timings from the system. And he had heard about this Datadog thing. What is the Datadog? Basically, this is the system for monitoring. It gives some analysis tools. You can create easily the dashboard. You can use the tracing, the metrics. So it's pretty awesome, basically. How we are going to integrate our system with Datadog? For that, we use statsd protocol. Initially, statsd was a server, but then it's more like standard, so that we define the, there are defined metrics already built in statsd. It's like counters, gauges, or histograms. We send those statsd metrics to agent. In my case, it's running on my local machine, and the agent sends the metrics to the Datadog agent. Sorry, to the Datadog. For that, I have used Statics library. Previously, I have used Elixir, but in the end, I think it's a pretty bottleneck as it uses only one Gen server. So for my application here, I use Statics library. And it's have pretty simple interface. You can increment. It maps to the counter, a gauge, and have a histogram. So in my example, the find by name resolver function, I just need to add the bump one lookup, which calls the increment function. And actually, we can see it here, as I have already integrated it. And a few minutes ago, I have run load test using the Postman that was already mentioned today. So I can see that there are some calls really in my application. So it's like one call per minute, but it's still something. I define the metrics like writing the lookups, and that's perfect, basically. So, except the custom metrics that we want to push, we'd like to instrument our frameworks that we use. So it's Phoenix. The basic idea of instrumenting the Phoenix is that we need to measure 2 times before our request is processed and after it's sent to the client. So as we may know that it uses plugs interface, so the request comes through every plug and it's sent back to the user. The solution is that we just record the start time when it comes in the beginning, and we need to calculate the difference time and send back to the Datadog. In my code, it's like this. So we have this plug, which simply calls the function register before send. So this is the crucial part of this. So there is defined the callback that will be called just before sending the response back to the client. So we can calculate the difference, which is end time minus starting time. For controllers and views, we can use the built-in instrumentation for Phoenix. Actually, I'm not using it here as I'm not having metrics from my application, but only from GraphQL. For Icto, I can see that we can use the log entry structure. So we need to define the callback. It's in module real-world.metrics, record metric. And this log entry structure gives me all timings regarding my call to the database. I'm using Postgres in this application. So in my example, the record metric will look like this, and we just simply create the histogram of our query. And in the Datadog, actually, as I refresh it, I can see that here I can have the metrics from the application, which is the query time. I can see this is like 11 milliseconds. And here I have created the diagram of the Ecto query. It's pretty okay. I mean, 9 milliseconds, fine. Going forward, we have this application, we have this shift, and we have created API for GraphQL. And we got the idea that we want to introduce new feature, so that once we query our recipes, we'd like to point out if it's veganic or not meal. So our shift calls the API, and it's pretty slow. So what is the issue actually? I like to know what is the issue, why my API is slow. And the chief calls his developers and he asks, guys, my application is slow, and they say, okay, we can debug the problem, we can use DBG or whatever. However, if we have like 1,000 calls per minute, let's say, in our application, it's pretty hard to debug this way, so that we, let's say, print like function calls to the view. So the chief is quite a smart person, and he says, okay, guys, so let's prepare the flame graph of our query, so that we can know how much time we have spent for each component of our application. So we have timeline, and we have root query, which is just the time of each query. And we have chills of this flame graph, and chills have chills, and we exactly could know how much time we spent on the components. And it's called tracing. And actually, it's possible to integrate it with our Datadog application. So for that purpose, I will use Spandex library. It's pretty simple, as each query is a new trace. Trace can have spans. Spans are those defined here. So it's session or DB. Those are spans. And the storage for each trace, so and the trace can have spans, is a process dictionary. It could be ETS as well, but let's leave it as a process dictionary as we don't have a distributed application. The usage of the library is pretty simple, as calling the start span and finish span. So again, how we are going to put it in our application. It's exactly the same as it was before. So we put start trace and end trace in our plugs pipeline. And we can use spandex Phoenix library as it does pretty much the same. So let's see how does it work actually on our dashboards. Okay, maybe I will zoom out. So again, I can see that there are some queries already done, and I can see the duration of the query and the resource, which resource is actually the query name, and the status code. When I click on one of those queries, I can see something that should be the flame graph, but currently is just one big bar. So we need to work on that now. So therefore, we have absinthe. As I was saying before, it's query language. And the idea for how to put the resolvers in our to our flame graph, we need to record the time before calling the field, and fields are processed sequentially, and after we does it. And there is a built-in instrumentation for that, so we can implement the middleware behavior. That's already done in it's already done in absinthe library, and in our project we do so as just starting the span before the field and finishing the span. And we obviously we need to put some metadata. It could be anything. We can put the GraphQL query, or in case of Ecto, we can put a SQL query, for example. So let's see how it might look like. I will just simply enable it in my code. Once again. And recompile the code. I run the query again. It's still slow, but now I can see actually what is the problem in our slow query with this Vejanic field. Okay, I have it here. So let's see some other queries. And oh, I can see that it actually took 2 seconds to process. So firstly, I can see the other queries. How does it look like? Yeah. So I can see that in our flame graph, we can zoom it out. How are the fields processed? This one is called title. So it's like 4 milliseconds. And this is the Vejanic one. And it took 230 seconds. So it's quite a lot. And this is called for each of the recipes. And the query is get all recipes. So it's called for every recipe. So now I can see that processing this Vejanic is problematic because it's called for each of the recipes, and it takes time. So we need to dig a little bit more in that problem. For Ecto, it's almost the same as it was before, but there's one difference, so that we call the callback we define in our log entry structure only once, and for the tracing we need to basically call it twice, before something happens and after it happens. But here we have to do a little trick, so that we create a span with the start span function. We finish the span, and actually having the query time, I mean how much time spent like the program for querying the SQL, we update our span so that we artificially like put it backward in the time. And we put it in the tracing structure. So I will do so in my code as well. I have prepared, fortunately, everything. And recompile the code. Okay, again, I call this, it's failed, it's loading. Okay, I call, and go back to my trace list, refresh the page. Sometimes it needs time to collect all traces. I have it, it's like 12 seconds ago. 1 second, and our flame graph had increased. We have ecto here. So the purple, not purple, it's red button. And we can actually see that for each, in the beginning, we have query for selecting all the recipes here because I put it as a metadata. And for each veggianic field, we actually see that it selects non-veggianic products. As a developer, I suppose the idea is that if we take our recipe and we want to know if it's veggianic, we just need to compare the ingredients with the non-veggianic ingredients. But seems that it is actually done for each recipe, and the query is pretty long. It's like 100 milliseconds or more. So I believe there's a lot of non-veggianic ingredients in the database. So if I actually look at the code, yeah, I will try to make it visible. This is our object for the recipe. We have this veggianic field. It's called function veggianic, and we can see that indeed it goes to the database for each recipe. So what could be the solution here? Maybe use the cache for fetching the product so that we call it only once. We don't need it to do it for every recipe. I will do so in this code, so I will just use with cache. This is my function. I have written it before. I recompile the code again. And I call it. Yeah, seems to be much faster than before. Let's see the graphs, how it's working really. And we can see that actually our all recipes query had speed up really. And when we see the graph, there is no more ecto queries for each veggianic field. So let's say we just optimize it. I believe there are better ways to do so, but this is just for the purpose of the presentation. Going forward, there's one more issue. What if I want to trace my own custom code? This is what I can actually do with wrapping the code, I mean the function, with like creation of the span, and after the function is called, we can finish the span. But we don't want to like modify the body of each function. So what would we simply do is that we can use the annotation with decorate annotation. And how does it really work? It is using the Decorator Library. And this is how the usage should look like, so that I just simply put it before my function. And this is of using the meta programming, as Adrian had a great talk regarding that. So I can simply explain how it works. We have provided the callback for our function, which is tracer. It takes arguments, which is the some metadata, the body and the context. The context have information regarding the module or what's the name of the function. We need to call the start span function before we call the body of the function itself. Then we finish the span, and we have to result the value of the function. So each function that will be decorated with this decorate annotation will have this processing. So we'll start the span, we'll call the body, and we will finish the span. I can do so in my code as well, but I think we don't have much time, but it's fine. Anyway, what are the issues of this tracing approach? So if you have a very huge architecture, you should sample the tracing so that we don't trace every call as it will be choking our system. And for that, there are configurable values like batch size or threshold options. The metadata size as well is very important, as we don't want to send huge bump of binary files for each query. So we just need to keep it in mind. It's hard to track the processes that call another processes asynchronously, as we store the stack of the spans in our process dictionary. So for that, there's something called distributed tracing, and it's supported in Spandex library as well. But as the all Phoenix requests are done in context of one process, it's fine to use the process dictionary for that. Tracing overhead, I have measured it with Xproof tool, and seems that it's like 2 or 3 milliseconds for spans that have like, for traces that have around 100 of spans. So it's pretty safe to use it even on production. And the most interesting question is about the telemetry, how it's going to be integrated, as my friend Arek is working on that from Krakow office. And they're pretty to work, but they need some time. I mean, in terms of few months, maybe it will be ready. But for now, I mean, the Spandex library is still the same. Just the instrumentation is changed. Other things is that I really experienced great support from Datadog, and it has introduced many features after I started using Datadog, so they evolve very quickly and fast. So that's all. Thank you very much, and yeah, that's all.